So now we're going to be talking about LeetCode problem number 2146, which is a medium level problem on LeetCode, and title is K highest ranked items within a price range. So let me just go over the problem statement first, and then we'll go over the examples, and finally the code part. So you're given a 0 index 2D integer array grid of size m cross n that represents a map of the items in a shop. The integers in the grid represent the following: 0 represents a wall that you cannot pass through, 1 represents an empty cell that you can freely move to and from, and all other positive integers represent the price of an item in the cell. So you may also freely move to and from these item cells. So basically 0 is wall, 1 is an empty cell which we can visit, 0 we cannot pass because 0 is an obstacle, okay, and all the other cells would be the prices of an item in the cell. So it takes one step to travel between adjacent grid cells, that is we are moving 4 directionally. So if you are moving towards right, up, down or left, it takes one step to travel to those. Now you're also given an integer arrays pricing and start, where pricing is equal to low comma high and start is equal to row comma column, indicates that you start at the position row comma column and are interested only in those items that have a price in the range of low to high. Both are inclusive. So the range of low to high is the prices that we'll consider from that cell, and you're also given an integer k. So you are interested in the positions of the k highest ranked items whose prices are within the given price range. The rank is determined by the first of these criteria, that is different, okay. So the rank basically is determined by the first of these criteria, that is in this order we'll go, that is the first highest priority we'll give to this first one, then second, then third, and then fourth, okay. So the highest priority is the first one, that is distance, which is defined as the length of the shortest path from the start. Shorter distance has a higher rank. So from the start, the point that is closer to it would be considered as higher priority than the point which has been placed farther to it, and this is obviously in terms of cells. So this is there is no diagonal movement. We are considering this distance like moving level wise, right? So with this basically distance, what we can understand is that we'll obviously have to use BFS since we have to find the length of shortest path here, right? So we are using BFS since we will be traversing the matrix, right? And we need to find the distance from the start cell. Let us say this was the start cell. So these two, that is 0, 1 and 1, 0 are basically at distance equal to 1, and then finally all the other cells are at a larger distance, right? Then secondly we have the price. So lower price has higher rank, but it must be in the price range that is mentioned here, right? So a lower price would obviously be ranked higher, right? Then the row number, that is smaller row number, has a higher rank, and finally the column number, smaller column, has a higher rank. So basically we need to find the k highest ranked items within the price range sorted by their rank, highest to lowest, and the rank is determined by these factors. That is, first the distance is considered, so a shorter distance, then the price, that is a lower price, would be considered, then the row value, that is r, and the column value. So basically we get the rank from this in this order, going left towards right. First priority given to distance, second to price, then third to smaller row, and fourth to smaller column. If there are fewer than k reachable items within the price range, then return all of them, okay. So that is basically our problem, and let me go over to the example part. So basically we have this grid, and for now let me just draw it on my own, right? So this is the grid, and just focus on this grid that I'm making, okay. So the grid that has been given to us is this, and the values that we have is 1 2 0 1, 1 3 0 1, and 0 2 5 1. All right, so basically we are starting at this position. We are given this is the start position, so this is the starting point, okay, and k is equal to 3, so we need to find only the top k elements, that is from this we need to find the top k highest rated values, that is 3 highest rated items, and the pricing is given, that is low value is equal to 2 and the high value equal to 5, okay. So firstly we see that we traverse it wherever we have 1, basically we can visit that, and 0 is basically unvisitable, so a non-visitable cell because it is an obstacle. So we can go down or we can go right here. So we go right because 2 is a higher price and we have to consider the price value, right, which is lying within this range, so we consider 2. Then we go down because we have 3, so we consider 3 and we add it, and then we have 2, so again we consider 2. Now we had to choose k is equal to 3 elements, so we already have these 3 elements, and the distance is basically in this order only, that 2 first is first we are getting 2, then we are getting 3, and then we are getting 2. Going over to 5, we also can go over to 5, so let me just add 5. But since 5 is at a distance of, that is 1 2 3 and 4, so since 5 is at a distance 4, we would not be considering it because we only need the first or the highest priority 3 elements, so that is 2 3 2, and we have to return the basically the indices of indices, not indices but the grid indices here. So basically this is 0 1 0 1, so this is basically 0 1, so we return that, then 1 comma 1, and finally 2 comma 1. So basically we have to return all these. These are the indices that have been marked in green, which we select as the highest k, or basically the k highest ranked items within the price range sorted by their rank. So you can see the explanation here as well. With the price range of 2 5, we can take items from all these cells, that is these cells along with the cell which has grid value 5. And the ranks we have found out using this criteria that I had discussed. Firstly, we'll consider the distance. So the shorter the distance, the higher the rank. So the first rank is basically given to cell 0 comma 1, that is it has a distance of 1. Then this one is given the second priority, that is 3, that is with distance equal to 2 from the start position. Then from the start position, distance equal to 3 is basically location 2 comma 1, which is this, and these are selected because we need only k is equal to 3 elements. And we also have this at distance equal to 4, but we won't consider it because it is not because we already have reached our final basically the k elements, so we do not have to exceed the k elements, so we don't consider 5, right? So therefore we output our answer as this. Okay, so this is the answer. So I think it was the explanation was quite clear. Now let us see another example. So in this example, you've been given this as a grid, and the starting point is now 2 comma 3. So this is the starting point, and k is equal to 2, so we only need to select 2 elements, right? So the price range is also given to us, that is low and high values are given, that is low is equal to 2 and high is equal to 3. So only cell values that fall within this range will be selected. So here you can see when we move towards 5, we don't select it because it is not falling in this range. Then we move to this point and this point, right? So these are at distance equal to 2, so we select 2 and 3 because they are falling in this range, right? So that is the same explanation given here. With the price range of 2 comma 3, we can take items from 0 1. Basically we can take this as well, and these items we are basically considering, not this because it does not fall in the price range. And also from the start, the least distance from this location is to this one, that is at a distance of 2, and this one, that is at a distance of 2 again. This one would be at a distance of 3, that is the node. Basically we'll have to go 1, 2 and 3 to reach this point, so the distance would be 3 here. And for this one we have to reach we have to take a path that has distance equal to 4. So these basically this is the same explanation given to us, right? The two highest ranked items in the price are basically placed here and that are marked in green, and this has been done because the ranking is in this order, right? So we have taken the rank in this order, and therefore we return the answer as this. So that's another example. And finally this example, let us see. We have a starting point at 0 comma 0. We need to choose top 3 elements, and the pricing is again 2 comma 3. So low value is 2 and high value is 3, and we start at 0 comma 0. You can see the cells marked in red are obstacles, so we cannot traverse them. So we go towards right, again we go towards right, again we go down. So that is basically distance till now is 3. Then we go here, now distance becomes 4. So at 4 we have distance equal to 4. Then we consider this one. This is basically lying in the price range, so we consider this and we take it. This is at a distance of 5, and next one we have at a distance of 6, right? So now you see that the item at 2 comma 0, that is 2, is at a distance of 6, and the item at 2 comma 1, that is 3, is at distance 5. So we consider this as the higher priority because it is at a distance that is lesser than the one at a distance 6, right? So therefore we would return 2 comma 1 first, that is basically, let me just show you, 0 1 2. This is the index how we are indexing it. So 2 comma 1 is considered first and pushed into this array or vector first, and then 2 comma 0, that is this one, would be pushed because this has higher priority because the distance is equal to 5, and this has lower priority as compared to this one because it has distance equal to 6, right? And since k is equal to 3, we wanted to choose 3 elements, but we see that there are only 2 reachable items within the price range. We cannot consider 4 because it is not falling in the price range, so we have to return this only, right? So the elements are elements should not exceed k is equal to 3, but if we are unable to find more elements, that is if we are falling short, we have to return that answer only. Okay, so that's it about the examples, and I think now you have an in-depth understanding of what is being asked in the problem. So now let me take you to my solution and how we are going to build the intuition for this. So basically let us summarize it. So we have a 2D grid, right, which represents a map in which we have the value 0, which is a wall, right? So we cannot visit it, we cannot visit these. 1, we have 1 stands for an empty cell, so we can visit these, and there are no items here because this is not in this, basically no items will be present here. But from basically values that are greater than 2, they are basically the cells which have items with prices, right? So these are the values at those cells, so that is given here, right? a start position row comma column is given, that is sx comma sy, right? So we start from these coordinates. Then a price range low comma high, and integer k, the number of highest ranked items that we need to return. Okay, so this is the problem, and our goal is to find out the k reachable items from the start cell whose price lies within the range low to high, sorted based on the following rank in this order. The order is basically the same ranking system that we used. That shortest distance is the most has the highest priority. So shortest distance from the start cell using BFS. So we use BFS because we need to traverse the matrix, right? So the shortest distance is at the first priority. Then we have lower price. So the cell with the lower price will be considered after the shortest distance. Then after these two, we have smaller row index, and finally we have smaller column index. So our aim is to return the coordinates of the coordinates as a list of row comma column. Okay, so that is the format of the answer. Now intuition, how we build it, let me talk about that. So this is a classic grid plus BFS traversal problem where we explore outward level by level, explore outwards level by level. BFS ensures that we are visiting closest item first. So BFS is also known as the level order traversal. So we will be traversing firstly, if this is the point that we are starting at, then it would go over to our coordinates 0, 1 and 0, 1. So sorry, yeah, 1, 0, right? So this is basically a grid that I'm making. Okay, so it basically considers the first level first. So this is the level 1, that is these two coordinates are at level 1. Then we have the value of, then we have 1, 1, right? Then we have 2, 0, right? And here also we have 0, 2. So then we visit these. So basically these are at level 2. These values at the diagonal are at level 2. Then these two would be at level 3, and finally this is at level 4 from the starting node. So we are basically performing BFS, right? And at each cell, if the cell contains a valid item, that is price, that is in a range and it is not a wall, that is if the grid value is not equal to 0, and if the grid value lies between the range that is low to high, and it is inclusive. So we have greater than equal to and less than equal to. So we record it and we store these values. To ensure that we return only the top key items, we will use a priority queue. So since we need top key items, we will use a priority queue, which is a minimum heap with a custom comparator that follows the ranking rules that we had, the 4 rules. And by combining BFS and heap, we respect the shortest distance, that is BFS guarantees this, and use the heap to efficiently sort and retain only the best candidates. Okay. So now let me talk about the key concepts that we are using. That is, firstly is BFS. Level order traversal used to explore all reachable grid cells in order of increasing distance. Ensures that when we find an item, it's among the closest possible items. Then the priority queue used to maintain the top k ranked items based on the 4-level comparison, that is distance first, then the price, then the row and the column. I've already discussed this in quite depth. Now, if size exceeds k, remove the lowest priority item, that is the worst among the best so far, right? If the size exceeds k, we have to remove the lowest priority item. Okay, and then custom comparator is basically we define the ranking as lower distance being better. If distance ties, lower price is better. If price ties, smaller row index is better, and if the row as well ties, then the smaller column index is better. This multi-level comparison is implemented using the custom comparator. I'll show you. Now the step-by-step approach I'll discuss, after which we'll get to discussing the complexity and finally the code part. Okay, so firstly we initialize. So get the grid dimensions m cross n. M is equal to the number of columns and n is the number of rows. Sorry, m is the number of rows and n is the number of columns. Store start coordinates and price range low, high. Prepare directions for movement for directionally, so up, down, left, and right. Create a visited matrix of size m cross n to avoid revisiting the cells. So standard, we are going to be following BFS, right? So declare a queue for BFS and initialize it with the start cell. Declare a min heap priority queue to store the best key items. Then we start the BFS traversal. Perform it layer by layer, so layer wise, to calculate the shortest distance from the start at each cell. If it's a valid item, that is the price falls in low and high range, push distance, price, row and column to the heap, that is the minimum heap, that is priority queue. If heap size is more than q, that is if the elements get greater than or exceed the value of k, then remove the lowest ranked element, that is the element which has the lowest priority. So we remove that by popping it out from the priority queue. And finally explore all 4 neighbors of the current cell and enqueue or push the valid unvisited neighbors which are not a wall. That is, valid would be basically which are cells which are in bounds. Unvisited basically in which for the cell, visited of cell is equal to false, that is it has not been marked as visited yet. And null wall neighbors are basically that are not equal to 0, right? And build the answer. The heap now contains the top k highest ranked items. Pop each item and extract the coordinates and reverse the final list because the minimum heap gives the lowest ranked items first. So we are reversing the final list because minimum heap gives the lowest ranked items first. I'll discuss now exactly what we are doing after discussing the complexity. So basically it is O of mn log k. So BFS visits each reachable cell once. So we're going over the grid, and since the grid size would be m cross n, it takes O of m cross n. And heap operations push pop are O of log k per insertion. So since we are performing BFS, and within that we are performing heap operations, that is pushing and popping, so it is O of m times n times log k. That is the time complexity, and the space complexity would be O of mn plus k. Mn for the visited matrix, and heap stores up to k items, so O of k for that. And also BFS queue uses up to O of mn in the worst case. So these are the time and space complexities, and now is our final time to discuss the code. So this is basically the coding part, right? So here I've commented out the part which is basically the summary. So 0 is vol, 1, the cell marked as 1 is empty, and other grid values are the prices, and pricing we have is low and high. So first our aim is to do BFS from the start cell to get the distance from cells. Then second is to collect only those cells that are reachable, that are not blocked by walls and have a price within the range low, high. And we use a minimum heap priority queue with a custom comparator to keep the top k highest ranked items in this order, and basically the same four comparisons that we do, right, as shorter distance, lower price, smaller row index, and smaller column index. Now let me show you the comparator that we have made. So the custom comparator for minimum heap we are going to use as this. So this would be used while building our priority queue. So bool operator, it takes vector A and vector of int type B. So firstly, A of 0 would store the distance. A of 0 and B of 0 are storing the distances. So basically, let me just show you what is our format. So the vector would be storing the distance, then the price, then the x coordinate of the cell and the y coordinate of the cell. So you see the A of 0 and B of 0 are the distance. So it first checks if A of 0 is not equal to B of 0, then we return A of 0 less than B of 0. That is the lower distance, that is this distance, has a higher priority. Then we check for the price, that is A of 1 and B of 1, right? So for price, if A of 1 is not equal to B of 1, then we return A of 1 less than B of 1. Then x coordinate, if A of 2 is not equal to B of 2, return A of 2 less than B of 2, right? So lower row index has higher priority. And finally, A of 3 and B of 3 basically corresponding to the y coordinates, lower column index has a higher priority. So basically this comparison custom comparator would basically do the work for the ranking for us, right, when we are building the priority queue and pushing elements into it. So that is about the comparator. And now isValid function is basically to check whether the coordinates that we are going to are inbounds or not. So I greater than equal to 0 and j greater than equal to 0 and j less than n, which is a less than the number of columns, and I less than equal to the number of rows. And directions basically top, left, going up, down, left, and right. So these are the four directions for the movement. Now we are at the main function. So basically this is the function highest rank k items. It takes the grid in and the pricing that we have, the start vector, and the k value that we have to choose from for our highest priority k elements, right? So basically m is number of rows, n is number of columns. We have initialized that. Then sx is equal to the starting the starts x coordinate, sy is equal to the starts y coordinate, and low is equal to the pricing of 0, high is equal to pricing of 1. So these are the low and high prices that will fall into the range. Now we define a queue for basically starting our BFS. So queue of pair int comma int type, which will store the x and y coordinates, and push the starting coordinates sx and sy. Then we check. Then we basically have maintain a visited matrix which is of bool type. So we mark our starting cell, that is visit of sx comma sy, as true, and distance we keep as 0 because we are starting from this sx comma sy, right? If let us say this is the sx comma sy, so the distance initially is 0 for this node, and then we keep traversing. When we keep traversing, it would be incremented in the iterations, okay? And min heap to store distance from start, price, xy. So we're going to be storing four values: distance from the start coordinate, then the price of the particular cell that we encounter, and the x and y coordinates of that particular cell, right? So we are maintaining it in terms of vector of int because it would be storing all these four values, and the comparator is passed here because that would help us in ranking our elements so as to get the top k elements in the order that we want, that is smallest distance first, then smallest price, then smallest x coordinate, and smallest y coordinate. So that is where we use the comparator function. So this compare function comes from here. This is the compare function. This is the custom comparator that I made and I discussed right now, right? So now we start our BFS function, that is while q is not empty, int len is equal to q dot size, which is the length of that particular level or layer. So while len minus minus, so going over to this layer, right? Current is equal to q dot front, so we get the current element from the queue and pop it out, and we basically get the x and y coordinates. Current dot first and y is current dot second. Cell price is basically grid of x comma y. So basically in the grid we have different values, right? So let us say 2 was here, 1 was here, 3 was here. So grid of xy is denoting the price of that cell. So that is why I've taken it as sell price. So we check if sell price is not equal to 1, right? So if the sell price is not equal to 1 and it is falling in the range, sell price is falling in the range low to high, right? That is, it is not an empty cell and the price falling in range low to high, then we consider this, right? And then we have to append, basically push it into the priority queue. Push that distance, sell price x and y coordinates into the priority queue. And we also put a check here that if the priority queue size is greater than k, that is, if the elements in priority queue exceed k, we remove the lowest priority element, since we only need to maintain k elements, the top k elements in our priority queue. And in case it goes over the size of priority queue, that is, in case k increases to, in case the priority queue size increases more than k, then we remove the lowest priority element to maintain the size k. So we pop it out. Okay. Now we are going over all the 4 directions, nx and ny, basically the x and y coordinates of the next cell that we are going to. We check if the cell is valid and the cell has not yet been visited, right? If the cell is valid and has not yet been visited, and also it is not an obstacle, so basically it is not out of bounds, it is unvisited, and it is not a wall, then we're going to mark the cell as visited and push it into the queue, right? So push the x and y coordinates of the cell that we are going to, that is the neighboring cell. And finally, when we basically come out of this while loop, that is, one layer or one level has been completed in BFS, we increment the distance level for the next BFS level, right? So once this loop would be complete, we'll have our the priority queue full, right? And all we need to do is basically get the answer in a format that we require, that is in vector of int type, right? So the priority queue is basically ready, and this is basically the answer, vector of int type. We just need to extract the top k elements from the minimum heap. So while priority queue is not empty, current is equal to pq.top, and we pop out the current element and get the x and y coordinates. So in the priority queue, it is stored in this format, right? Distance, price, then after price we have x and y coordinates. So basically, current of 0 would mean distance, current of 1 means the price, and since we only need to return the x and y coordinates, that is current of 2 and current of 3, right? That is the x and y coordinates. So you see, current of 2 and current of 3 are the x and y coordinates. We get those out and push those into the answer, right? And finally we reverse our answer because the heap pops the lowest rank first, and what we need is that we need the highest rank first in our vector int, right? So basically, to get the highest rank, we need to reverse our heap, sorry, reverse our answer. Okay, so that's basically it, and we finally return our answer, and that's how you solve this problem. So let me just submit it once again to show you whether it's getting accepted or not. And yeah, it has been accepted.